Hello again. This is Math 0465 coming to you from the College of DuPage, and this is a lecture aligned with section 1.2 in your textbook, Getting Started Reviewing Pre-Algebra. As always, please be attentive while watching these videos. A Venn diagram is a graph that helps compare and contrast sets. Each set is represented by a circle, and the circles have elements in common which overlap. The circles are usually enclosed in a box which represents a larger set and provides a space for elements that do not belong to anything within any circle. So for example, the Venn diagram on the right shows the prime, even, and whole numbers between 1 through 8 inclusive. This means that 1 is not prime and it's also not even. The prime numbers 2, 3, 5, and 7 are shown in this circle, and the even numbers 1 through 8, 2, 4, 6, and 8 are shown in this circle, and you see that 2 is common, it's a prime, and it's an even prime. So that's an example of a Venn diagram. And what we're going to do is ask you to do some self-analysis about your pre-algebra skills, and a Venn diagram is useful for helping you do this. So this allows you to indicate the level at which you can perform each skill shown in the table on the following page. Now, each circle of the diagram addresses one of the three facets of learning math discussed in this book: skills, concepts, and applications. So this circle here says I can perform this skill. So that's in that circle. This circle over here says I can explain how to do this skill, not just do it, but explain how to do it. And this third circle says I can apply this skill to a new situation. And this region 8 that's shown out here says you can't do any of those. So the question that's being asked here is, what does region 1 represent? Region 1 is this part of the circle up here. And what is region 8, which is out here? What does that represent? So write down in a phrase what those regions represent, and then we'll see how you do. Let's see how you did. Okay, so region 1 up here says you can perform the skill, but since it's not in this circle, you cannot explain how to do the skill, nor can you apply it. You just know how to do the skill. Now region 8 says you don't know how to do any of those three things with the skill. Now what we're asking you to do is to take this Venn diagram about performing the skill, explaining how to do the skill, and applying the skill to a new skill. And we're asking you to do that. Take these letters of these skills shown by these examples, and A through O, and place them into the Venn diagram. Now there's no right answer because you're really doing an analysis of your skill, but this helps you figure out where you are as you're going into this course. So I'm going to ask you to do this, and I'm going to pause the video for a time for you to do this. So pause now. And again, there's no right answer, but hopefully you did that and you can apply that knowledge going forward, knowing what you know and maybe what you do. Now, since some of those skills may be rusty, we're going to review a few basics in these examples. So number 4 says, in a class of 20 students, 17 of them passed a skills test on the prerequisites. What percent of the students passed this quiz? Now, instead of using a calculator or division to solve this problem, we are asking you to create an equivalent fraction, and this is known as scaling. And creating equivalent fractions is necessary when you add or subtract fractions that have different denominators. So please give it a go. Let's see. Well, 17 out of 20 is the same thing as you multiply the bottom by 5 and the top by 5, and you get an equivalent fraction that is 85 out of 100, and 85 out of 100 is what we say percent, so that is 85%. So that is the answer you should have gotten, and I did it using Excel here. Let's look at another example. A student is planning a summer semester of study abroad and has made an initial down payment of 20%. She then has 2 required payments during the spring semester, each 1/4 of the total. what fraction does she still need to pay for the trip abroad after making all of these 3 payments? The initial down payment and each of the quarters. So please pause the video and give it a go. Let's see. Okay, so 20 out of 100 is the same as 1 over 5. And she makes 2 more payments, which are a quarter each. So this is 1/4 and this is 1/4. So you see what we have to do is we have to add these together and come up with our answer. Okay, so what's going to happen is this is the common denominator here is going to be 20. And so what you have is this is 4 over 20, this is 5 over 20, and this is another 5 over 20. So when you add those, you get 14 over 20. But 14 over 20 is the same as 7 over 10. And so that means that the student still needs to pay the whole thing is the whole price for it. They paid 70% or 7 out of 10, so they still need to pay 3 out of 10 or 3/10 or 30%. And it asks for a fraction, so that would be 3 out of 10 of the total cost that they still need to pay. Here's another problem. At a particular college, half of all freshmen start in developmental math. Of those who start this level, 4 over 5 start in beginning algebra. What is the chance that a freshman at this college starts in beginning algebra? Give your answer as a percent without using a calculator. Okay, so pause and think about this, come up with an answer, and we'll see how you do. Let's see how you did. Okay, and so 1/2 of all freshmen start in developmental math, and then of those who start, 4/5 start in beginning algebra. So you're going to multiply these two fractions. So you multiply across the numerator and across the denominator. So that is going to be 1 times 4 is 4, over 2 times 5 is 10. So that is 4 out of 10, and that means in lowest terms that is 2 out of 5. But they ask, give your answer as a percentage, so 2 out of 5. 2 out of 5, to have an equivalent fraction, you multiply the bottom by 20 and the top by 20, and you get that is 40%. Now we use this idea of equivalent fractions to add or subtract fractions. And the steps involved in adding or subtracting fractions is you rewrite the fraction with a common denominator if it's necessary. Then you add or subtract the numerators and you keep the same denominators and simplify as needed. So here is the example of 7 over 8 minus 1 over 5. And you realize that the common denominator between these is 40. So here you have to multiply top and bottom by 5, not changing the value of the function. That's 35 over 40 minus, here you multiply top and bottom by 8. And you get 8 over 40. So 35 over 40 minus 8 over 40 is 27 over 40. And that is in lowest terms. Now, it's different if you multiply or divide fractions. If dividing, you take the reciprocal of the second fraction, make the operation multiplication, and simplify if possible. You multiply the numerators and multiply the denominators once you've changed it into a multiplication problem. Now here's another problem for you to consider. Suppose a student stands with her back against one of the classroom walls. It's a rectangular classroom, and she walks halfway to the opposite wall and then stops. She then walks half the remaining distance to the wall and stops. What fraction of the length of the room has she walked after doing this process 3 times? After 4 times. And the question is, will she ever technically reach the opposite wall? So please give it a go and we'll compare notes. Let's see how you... Well, the first time the student walks 1/2 the distance to the other wall. And then she walks 1/2 of that. So she's walked 1/2, but then she walks again a second time, half. So she's adding 1/4 to 1/2. She gets 3/4. And then the third time she does this, she's going to walk 1/2 the first time, 1/4, and then 1/8, which adds up to 7/8. And when she does this a fourth time, she'll reach 15/16. She will never reach the other side of the wall. This is a concept related to limits, which is something that is studied in the math subject called calculus. Okay, now let's return to Venn diagrams and sort of accounting. Now you notice that if we're wanting to know how many things, the number of things that are in A union B, or A or B, it's going to be the number in A plus the number in B, but then you have to subtract off the common amount that's in the two sets, because this is double counted. If you take the number in A, you count what's in Z. If you take the number in B, you count what is in Z. So you see you double counted the numbers that are in Z. So the number in A or B, or A union B, is the number in A plus the number in B minus the number that is in A and B, or A intersect B. So that is the formula, and that's the Venn diagram discussion. Talk about having three sets. Now this is more complicated though. So if you take the number in A, the number in B, and the number in C, and add them together, you end up doing a lot of double counting. So you have to subtract off these pairwise intersections, but then you've subtracted off what's in the middle more times than you need to, and so what will happen, you have to add it back one more time. So you want to ponder this a little bit, but the size of A union B is the number in A union B union C. A or B or C is the number in A plus the number in B plus the number in C minus the number in A and B minus the number in A and C minus the number in B and C, and then you add back the number that are in all three sets, the number in A and B and C. Now let's apply that. So for the purposes of this market research, a survey of 1,000 women was conducted in a town. The results show that 52% liked watching comedies, 45% liked watching fantasy movies, 60% liked watching romantic movies. Now, since this adds up to more than 100%, there are people who like more than one. In addition, they learned that 25% liked watching comedy and fantasy, both. 28% liked watching romantic and fantasy both, and 30% liked watching comedy and romantic movies both, and 6% liked watching none of these three movies genre. So there's three questions that you're being asked in this problem. How many women liked watching all the three movie genres? What's the number of women who liked watching only one of the three genres? And the third question is, find the number of women who liked watching at least two of the given genres. I'm going to pause while you work on this thing that is called a survey problem. Let's see how you did. And let's introduce some notation. So the number that liked watching comedy was 52%. That's the percentage. The percentage of women who liked watching fantasy was 45%. The number who liked watching romantic movies was 60%. Now, these are percentages, and the number that are in C and F, that is comedy and fantasy, was 25%. The number who were in fantasy and romance were 28%. And the number in comedy and romance were 30%. Now 6% liking none of these, so the number in the union doesn't add up to 1. It adds up to 1 minus the 6%, or 94%. So we're going to use that Venn diagram formula that we just had. So we have 94% minus 52 plus 45. Excuse me, I said this wrong. This is 94% is equal to 52% plus 45% plus 60%. We add it all together, but then we subtract off the pairwise intersection. So it's minus 25%, minus 28%, minus 30%, plus this is the number that liked all three, which you don't know what that is. But this is an equation that you can solve, because what you can do is take all of these numbers and you can solve for the percentage that is here. Now that means that there are 20% that are in this this total, and that allows to answer the problem that the number of, and we fill out the Venn diagram, we got 20% there, and we put all of these others numbered in this way. So the number of women who liked watching all three genres was 20% of 1,000, or 200, because 20% times 1,000 is 200. The number of women who liked watching only one of the three genres was so only one. You're taking this number, and this number, add those together, and you get 51%, and so that is 510. And the number of women who liked watching at least two, that would be at least two is these, and these, and you have to worry about those. And so there is 10, 5, 8, and 20. And so that's going to be 43%, or 430. So the answers you should have gotten were 200, 510, and 430. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself, because self-care is important, and of each other, because we're all in this together. God bless you all, and more math to come.